So our first question comes from Alex in Perth, a lovely question about light moving through space and the idea that how can light be both a particle and a wave?
It's a brilliant question, that. I mean, that's the fundamental question that we were forced to ask in the 1920s. So, and actually before then, in fact, go back all the way back to 1905, in fact, and Einstein. So experimentally, we find that in order to describe the way that all particles behave, then you can consider them as particles. So point-like things. So when they interact in particle physics, what do we see? We see essentially a game of billiards, right? We see things with mass, or indeed with no mass, in the case of photons, little particles bouncing off each other, like a.
We have a lot of fruit.
Like that. That's what we see. However, in order to describe where they're going to go, so you can ask the question, I've got a particle here, where's it going to be at some later time, which is, I suppose, the fundamental question you ask in physics or dynamics, where's it going to go? Then you find that you have to, the mathematics that describes where it's going to go is very wave-like, and so particles behave like waves in the sense that if you want to calculate where they're going to go, you end up with things you get with waves, properties of waves. So, for example, with a wave, you can get what's called interference, which means that the peak of one wave lines up with the trough of the other one, and the waves cancel out. And you get that with the way that particles move around. So I suppose the best thing to say is that my prejudice, and this is a prejudice actually, my feeling is that particles are particles, and that's the way that particle physicists tend to think about them. But the way they move is not like the sort of particles we can imagine. So they don't just, if you hit them, if you bang these two together, you go boing, and that one goes off, and you can calculate it all using simple. You can calculate it, but the maths you use is quite wavy and wave-like. So that's the way I look at it. I mean,